the last video, we showed that tan theta equals sine theta over cos theta and cotangent theta equals cosine theta over sine theta. We also need to note that we do have a restriction here that cosine theta cannot be 0. Cosine 0 cannot be 0, and additionally, cotangent, or sine theta rather, also cannot be equal to 0. You always have a restriction whenever you have a rational function with a variable in the denominator, and in both of these cases the variable is theta. The angle is the variable. Now, based on the diagram that we produced in the last example, can we now prove that sine squared theta plus cos squared theta equals 1? Now, if you recall the Pythagorean theorem, you know that a squared plus b squared equals c squared, where c represents the hypotenuse and a and b are the side lengths of a right angle triangle. Based on this diagram, if we started off with a squared plus b squared equals c squared, we could rewrite this as x squared plus y squared equals r squared. And we showed that x is equal to r cos theta and y equals r sine theta. So I'm going to continue down here. Let's continue this down here. If x equals r cos theta all squared plus r sine theta all squared, and that's equal to r squared. Okay, I'm just going to square everything within the brackets. R squared cos squared theta plus r squared sine squared theta is equal to r squared. I want to note, let's just do a side note, that this may be kind of odd that cos squared theta is actually the same as cos theta squared, and sine squared theta, that's actually what that really is sine theta squared. So this kind of looks weird and less intuitive, but this is all it is. Okay, if we divide both sides by r squared, get rid of that, get rid of that, get rid of that, and what we're left with is our identity that we wanted to prove. Cos squared theta plus sine squared theta is equal to 1. We call this the Pythagorean identity. Pythagorean identity. It's actually one of 3 Pythagorean identities. So we correctly proved that, and as a bonus, we can produce 2 more, and I'm going to do that right now. So what happens if we divide both sides by cosine theta? If I divide both sides by cosine theta, cosine squared theta rather, I'm going to get cosine squared theta over cosine squared theta, that's going to be 1, sine squared theta over cos squared theta, and 1 over cosine squared theta. So what I'm doing here is dividing both sides by cosine squared theta. Okay, anything divided by itself is 1. I'm going to rewrite this. If we acknowledge that sine squared theta is really this, cos squared theta is really this, then we can rewrite this as sine theta over cos theta all squared. And this can just be 1 over cosine theta squared. Okay, if we square both things, square the numerator and the denominator here, then we get this previous step. We know that sine theta over cosine theta is tan theta, so this is going to be tan theta squared. And this will be, well, this is just a reciprocal trig ratio, so this is secant theta, and that's also squared. So right now we have another identity, and that is 1 plus tan squared theta is equal to secant squared theta. This is considered to be a second Pythagorean identity. I'm going to show you a third Pythagorean identity. So, see that over here. Instead of dividing both sides by cosine squared theta or cosine theta squared, we're going to divide both sides by sine squared theta. And what I'll get will be cosine squared theta over sine squared theta plus sine squared theta over sine squared theta rather, and that's going to be 1 over sine squared theta. Okay, just applying the same algebra that we did in green. This is just going to be cosine theta over sine theta plus, this is just 1, and this is going to be 1 over sine theta all squared. Okay, we can think of this as 1 squared. Okay, this you can think of that as 1 squared. Cosine theta over sine theta, it's the opposite or the reciprocal of tan theta. That's cotangent theta. Cotangent theta squared plus 1. And this is going to be the reciprocal of sine theta, so that's cosecant theta. Cosecant theta squared. And just rewriting this, this will be 1 plus cotangent squared theta equals cosecant theta squared, or cosecant squared theta. Okay, so these are 2 more Pythagorean identities. And Pythagorean identities. And these can be used to prove other identities. And what a identity is, a trigonometric identity, is basically a mathematical statement that is true no matter what value of the variable you have, no matter, in this case, the variable's theta.